This video we will be solving systems of equations using three variables. This is a joke worksheet, so the question is, what's brown and sticky? As we're going through, you can probably try to figure it out as we take a look at the options and our answers. I'm going to start off with number one. Now these look pretty scary because there's three variables, there's three systems, or there are three linear equations in the system, but it's actually not too awful. You just need to remember the steps that we have to take. The first thing we're going to do is we're going to use elimination with the first two equations and the last two equations. So we are using that middle equation twice. Now we want to cancel out the same variable each time. So if I cancel out x in the first system, then I need to cancel out an x in the second. Or if I do a z, I need to cancel out a z. I'm going to write my two systems so it's easier for me to tell which one I probably want to cancel out. 8x minus 3y plus 4z equals 62 with the 2x minus 5y minus 4z equals negative 8. So that's my first two equations. And then here's my, I'm going to use a different color. I have 2x minus 5y minus 4z equals negative 8. And 4x plus 2y minus 4z equals 20. When I'm looking at canceling out x's or y's or z's, I see that z's are probably going to be the easiest one because in the first system, the z's already cancel. So now, if I remember with elimination, once it cancels, we add them together. I get 10x minus 8y, oops, my bad, moved it, equals 54, because it was 62 minus 8. Over here, the z's don't cancel out right away, so I'm going to have to multiply one or the other by something in order to make it cancel. I'm just going to multiply my first equation by a negative 1, which just essentially changes all of the signs, making this minus 2x plus 5y plus 4z equals 8. Now you can see how the z's would cancel. And I'm adding these two systems together, so that gives me 2x plus 7y equals 28. So I like to call this my new equation 1 and my new equation 2. Now what we're going to do, so first step was to use elimination in the first pair and the second pair. The second step is to do the process of elimination with our new equations. So now what we're going to do is I'm going to write my new equation 1, 10x minus 8y equals 54, and my new equation 2, 2x plus 7y equals 28. I'm going to use a process of elimination. Looking at my y values, I could multiply each in order to cancel it out, or I could, if I wanted to cancel out the x's, just multiply my second equation by something to cancel out the 10x. So what would cancel out a 10x is a negative 10x, so I'm going to have to multiply 2 by negative 5. That'd give me 10x minus 8y equals 54, so I just rewrote the first equation, and now I'm going to multiply the second by negative 5. So negative 10x minus 35y equals, that's going to be negative 140. Now I'm going to add them together so the x's cancel, which is what I wanted. And then I need to do negative 8 minus 35, that's a negative 43y, and 54 minus 140, so I would have a negative 86 here. Divide each side by 43. That gives me y equals 2. We've solved for one of the 3 variables. We need to solve for x, y, and z. I have y. Time to find x. You're going to take y and plug it into either your new equation 1 or new equation 2. It's up to you. I think the math will be a little bit easier if I use the new equation 2, so that's what I'm going to use. 2x plus 7 times y, which is 2, equals 28. That gives me 2x plus 14 equals 28. Subtract 14 on each side. 2x equals 14. Divide by 2. X equals 7. So I have x, I have y. Time to find z. To find z, or your third final variable, you're going to take the 2 values that we know, and we're going to plug it into one of our original equations, because that's one that has the z in it. It does not matter which original equation you use to plug it in. I'm just going to pick the first one, or the second one. The math looks a little bit easier as well. I don't know. It's personal preference. Pick whatever one you want. I'm just going to do the first one. It's 8 times x, which is 7, minus 3 times y, which is 2, plus 4z equals 62. 8 times 7 is 56, minus 3 times 2 is 6, plus 4z equals 62. 56 minus 6 is 50. So I'm going to subtract that 50 from each side, leaving me with 4z equals 12. Divide each side by 4. Z equals 3. That means our final answer, which needs to be written as a coordinate, should be x, y, z. So x is 7, y is 2, z is 3. We just found out that the answer for 1 was 7, 2, 3. So if I'm looking at the letters, 7, 2, 3 is C. So in our question, let's put a C for 1. Now I'm going to do number 2 with you. Remember, the first step is to combine the first 2 and then combine the second 2. So my first equation would be 3x minus 8y plus 5z equals negative 5. 2x plus 10y plus 5z equals negative 10. Just by writing out that system, I can tell it's probably going to be easiest for me to cancel out the z's. You could cancel out whichever one you wanted, but it's just, I'm trying to make it easier on myself. So I'm probably going to cancel out the z's on this one, because I would just have to multiply one of the equations by a negative 1. And then in the second system, we have the 2x plus 10y plus 5z equals negative 10, and 5x minus 4y minus 2z equals 33. They already have different signs, but we have a 5 and a 2. So the next common multiple for a 5 and a 2 would be 10, meaning I'd have to multiply this first equation by 2, and I'd have to multiply the second equation by 5 in order to cancel out the z's. So let's see what that looks like. To get my new equation 1, I'm multiplying my second equation by negative 1. It's just essentially changing all those signs for me. You can see how it would cancel there, and I'm left with x minus 18y equals 5. And then for the second equation, if I multiply by 2, I get 4x plus 20y plus 10z equals negative 20. And if I'm multiplying by 5, I get 25x minus 20y minus 10z equals 33 times 5, which is 165. Now for this one, notice how the y's cancel and the z's cancel. So my goal was to cancel out the z's, but the y's happen to cancel as well. This is awesome because when I add, I end up with 29x equals negative 20 plus 165, which is 145. Now, I have the capability to solve for x. Just divide each side by 29. And that does give me a whole number of 5. So once we found our new equation 1, new equation 2, which we did do here, our next portion was to solve for the variables. I already found one of the variables. So now I can take this and plug it in to my new equation, number 1, which is x, which is 5, minus 18y equals 5. Subtract 5 from each side. That gives me negative 18y equals 0. Divide each side by negative 18 to get y by itself. Y equals 0. So my final answer, in order to write that, I need to get z now. So I have 1, 2. For z, we're going to have to plug into one of our original. Doesn't matter which one you want to do. I'm going to go ahead and plug it into the first equation just because it kind of looks easier. So it's going to be 3 times x, which is 5, minus 8 times y, which is 0, plus 5z equals negative 5. So I'm going to solve that for z. That would give me 15 minus 0 plus 5z equals negative 5. So 0 is basically gone, minus 15 on each side. I get 5z equals negative 20. Divide by 5. Z is a negative 4. So the final answer is 5, 0, negative 4. If you take a look at the letters that correspond, 5, 0, negative 4 is S. So that means 2 is S. In-person students are going to use the remainder of the time to try these 4, and you're going to complete the joke. Remote learners, all of this is your homework, and in person, if you don't finish this in class, it does become homework for you as well. You must show all of your work in order to receive credit, but in order for you to check your work and make sure that you're getting the correct solutions, I will tell you what the answer is. What's brown and sticky? Well, that would be A, stick.